Okay, so this is this is approximately where we left off with yesterday. All right. Now, according to early models of what an atom would look like, we said yesterday it was theorized that these were just spheres of molecules where the electrons were actually on the surface. So what you would do is picture, for instance, uh, a shot put. Let's make this a little bigger. A shot put, because that would be a sphere. It's theorized that those electrons were actually on the surface of that shot put. But we know that's not the case now. We look at what this modern atomic model says. The electron cloud is where you would more than likely find these electrons, which it is true, and you find them in various what levels? And it's and various energy levels. So, when you are looking at that periodic table, how can you tell which energy level you're in? What does that have to do with this guy right here? Periods. Periods are the same as energy levels, with one exception. Okay? And that is when you go from element 19 potassium, element 20, element 19 potassium, element 20 calcium, that is 4s1 because that's the fourth period there, correct? But once you reach scandium, element 21, what does your slide rule tell you? It goes from 4s2 to what? To 3d. Okay? So that's why utilizing that slide rule is so important. It makes that correction for you. Okay? So when we say utilize these periods, that is exactly what we want you to do for the S block and the P block, but you got to be careful with the D block. Just picture N minus 1. So if we put 4 in for N, okay, just like we said there, so potassium and calcium, if we put 4 in for that N and subtract, that gives you, of course, 3. So that's why utilizing, again, that slide rule is so important. Okay, so moving forward, okay, and from that video yesterday, notice they started saying element 79. What they're talking about, okay, is not only just the atomic mass, but also the atomic number, okay? Because they would say 79 protons, 118 neutrons, okay? And we'll go on and explain that here in just a moment. Like I said, what we're doing here is setting up, I'm guessing, perhaps the 15th, which would be next Wednesday, maybe maybe the 16th, next Thursday, we'll have an activity to utilize to show what this atomic model would look like. So when we're solving for this atomic mass, we'll show you how to do that using your algebraic skills, just like what you did last semester, right? Using algebra. Just what you wanted to hear, right? See, that's the way we approach that. Say yes. All right. Does everyone have this information that wants it? Okay. So again, if you don't have your periodic table out, please get it out now. Pick a number, any number. Well, we did that already. Pick another one. 15, okay? So what do we mean by saying, let's talk about element 15? First of all, which one would it be? You are correct. Why are you right? Because when we're referring to these elements, when we say element 15, we're identifying the atomic number, which also is telling you the number of what? And that will never change between any element of phosphorus. It will always have 15 protons. Okay? It may have different numbers of neutrons, and it certainly will have different numbers of electrons. And we'll show you what that means here in just a moment. So as you look at your periodic table, again, you got that big box up here on top, okay? So in each element box, it tells you 5 things. 1, 2, 3, yeah. It's atomic number, it's valence charge. That doesn't mean anything to you right now, but we'll establish what that means here in a moment. Of course, it tells you the symbol, which we said phosphorus, so it's just letter P, all right? And then tells you the name, okay, phosphorus, and then the atomic mass. And what that means, any element, that mass number, that's just another way of saying atomic mass, because it's the protons and neutrons together that make up the mass of each element. And we're not forgetting the electrons. It's just that their mass is so small that we can disregard that, for instance, okay? Because I believe the protons and neutrons are about 2,000 times larger than that of the protons and neutrons. That's why we say you can disregard that. Okay, just want to do one more slide, and then I have some information on the back of this screen that we want to go over. Okay. Also explain what this means right here as well. this information that wants it. Not quite? Okay. Do you ever think of one of the things that we've noticed already? How smoothly it goes in here when you're doing the things you're supposed to be doing. It's probably why basketball players are doing so well. Volleyball players, you might not think it was a good season, especially football players. When you keep doing the little things right, things just go so much smoother. Okay, does everyone have this? Okay, so what we mean by what we just talked about today, okay, if we were to add together the numbers and letters that you see in each example, we can identify those elements just by looking at it. So, would you want to approach this in order, or do you want to pick which one you'd like to talk about? E stands for electron. Because it's easier to write an E as opposed to a 1, because otherwise it might blend in with the energy level. That's why. That's a good question. So, how would you like to approach that? Just go in order? Just go in line. Okay, so when you add all these together, what do we get? I don't know, got to get my calculator out. Say that again? Okay, so if we say 37, which is what we meant to do, and that's right, so if we did this, although I should be able to write 37 better than that, what are we talking about when we say 37 protons? We're talking about a very specific element. What would that be? Rubidium. Why are you right? Okay, so remember, the atomic number is the number of protons in the nucleus, and it tells you which element you're dealing with. That's right. Okay, what about when you add all these together? Okay, so this one is which element then? Potassium. I should probably make rubidium. Potassium. Okay, pretty simple. I guess P equals 1. What about down here? Okay, protons equals 20. Okay, that's calcium. What about up here then? Okay, so protons equals 3. Lithium. Okay, and then finally this one. Okay, now go ahead and pick any one of these three. The middle one. Okay, so sodium. So what that means, protons equals 11. Remember, this is what we're dealing with. This is the atomic number of protons. We said today that the number of neutrons plus the number of protons equals the atomic mass. So the atomic mass is this guy up here, or 23. So protons plus neutrons equals atomic mass. Okay, not atomic number or mass number. The mass number and atomic mass means the same thing. Because the atomic mass for sodium inside that box says 22.999 something, I believe. So we round that up to 23. So that's what the number of protons and neutrons together equals 23. So we're going to ask you, well, how many neutrons does sodium have? Well, Which of these three variables, we know two of them. Which ones? Protons we know, which is what? 11. So now that we said you're going to use your algebraic skills, how do you get neutrons by itself? Subtract the 11. 11 from 23 would give you what? So inside that nucleus, along with the protons, you have how many neutrons now? Okay? All right. Right middle. Are we on the bus? Right middle. Right middle. Okay? Left outside. Okay? Right outside. Middle. Okay? And left middle. Okay? So, now let's go ahead and pick something out of here. One of these, not hydrogen. The bottom one. Okay, so what I want you to do, tell me everything you know about this element. So the blanks, well, I want to know the number of protons, the number of electrons, and the number of neutrons. 20 protons, you're right. You could do that just like that. Why are you right? Atomic number identifies it. There's 20 in there. You can count all these numbers and letters. There's 20 electrons. And how do we get the number of neutrons? And you can do that every time, or really all you're doing is just subtracting this number from this one and getting 20. Okay? Now, the number of protons and neutrons is not always going to be the same. Okay? For about almost the first 10 elements, a lot of them have the same numbers, but as we can see with sodium, that's not the case. With calcium, they do have the same numbers, but they don't always. Okay? So to finish this quickly, how many protons does potassium have? 17. Okay, how many electrons does it have? And then if we said 17 down here, and then I want to say, is it 40? 30, okay, 39. I guess it would have to be if calcium is 40. So now, how do we get the number of neutrons? You subtract the two, just like what we did here. So 17 from 39 gives you, okay, now, left middle. On the bus, okay, right outside, okay, left outside, and middle, okay, and right middle. Okay, so, and we can do that for any element, but the last things I want to illustrate, this, I'm circling these, all these ones that I'm circling. Can anyone see a pattern that they all have in common? Column. You're right. What about it? Oh, close. It is the same block. What's a vertical thing called? Column. So what column is hydrogen, lithium, sodium, potassium, and rubidium in? The first column. So why would these be circled? How many electrons do they have in their outer energy level? 1. So if we move to the right 1, to beryllium, magnesium, calcium, strontium. Did I skip one? Beryllium, magnesium, calcium, strontium. What do we notice about calcium? How many electrons are in its outer energy level? Okay. What about magnesium? Like this here? I just wanted to see if I could confuse people by just putting E's. You can put 2 there. Okay. So, the column that it falls into tells you how many valence electrons it has. But we got to skip that D block. So someone pick a number between 5 and 10. 7. Okay. Nitrogen. In columns 1 through 8, what column is nitrogen in? It's in the 5th. Now, it's in the 3rd column of the P block. It's in the 5th column of the 2nd period. So why do you suppose, why is that number 5 so important? It's going to have 5 electrons in its outer energy level. That's right. So, and we've done this before, so very quickly. Protons equals 7. Neutrons would be how many? You're right. Why are you right? It has to equal 14. This is where that's coming from. 7 from 14 gives you 7. Okay, following our slide rule, 1s what? 2s, 2p, 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 2p. Okay, remember. Okay, it can hold 6, but in the P block, it's in which column? 3. But in the entire energy level, it's in the 5th. So when we put them 2 together, these 2 tell you which column it's in. Always. It will always tell you which, if it's neutral. It will always tell you which column it's in. So again, that's a repeating pattern that periodic table is trying to tell you. Yes, except for which block? Except the D block. There you got to be careful. Okay? Again, if we're saying we understand this and we don't, it's not going to get any better. Okay? And it's not a reflection on whether you think, oh God, I'm dumb, I can't get this. Well, I would say that would be true if you're not going to put forth any effort, but I don't think anyone would do that. So if you don't, what I say, except for being on the outside rows, if you're struggling with this, look to your left, look to your right, okay? Chances are there's someone that can help you. Like we said, one of the juniors, if you said, Cole, can you please help me with this? It doesn't have to be Cole. It could be Weston. It could be Noah. It could be Willow. It could be Olivia. Any one of those, I'm sure, would be willing to help you with this. All right. Are we good? Okay. So, and I know some of you said, I don't get this. Well, please take initiative to get a handle on this. All right. So we see that vocabulary is due on Thursday, and some of them might not be in the back of the book. They might not be in the chapter. Think about what those terms are, and we will address that tomorrow. Make sense? All right. So we're going to continue with that video. We'll catch up to you next time.